European Reduced Vertical Separation Minima, European Rvsm Operational Overview. This brief overview addresses considerations which will affect crews operating in a Reduced Vertical Separation Minimum, or Rvsm environment, in European airspace from January 2002. Aviation has changed. Technology has evolved along with the increasing demand for traffic capacity and speed. Rvsm is the natural answer to the need for more traffic in European airspace. The European Rvsm programme began in 1997 after an initial planning phase to assess its operational safety, costs and benefits. Rvsm will continue to be monitored after the implementation date in order to ensure that the long-term safety objectives are being met. On the 24th of January 2002, the airspace of all ECAC states, together with that of Tunisia and Morocco, will be significantly transformed when the programme is put into operation. European Rvsm allows for the application of a 1,000-foot vertical separation minimum between suitably equipped aircraft in the level band flight level 290 to flight level 410 inclusive. This Rvsm airspace will adjoin the North Atlantic Rvsm area, thus creating a single block of airspace from the eastern seaboard of the USA to Turkey. The objective of this air traffic management project is to provide enhanced capacity by providing the airspace users with more flight levels and more possibilities of optimizing flight profiles, and increasing airspace capacity, which in return reduce ATC delays. The introduction of Rvsm will bring changes in daily route procedures for air traffic controllers, air crews, and aircraft operators. The impact of these changes will be evident during flight preparation and operation, in particular, during short and long-term flight preparation, during pre-flight and in-flight procedures, and in case of Rvsm contingencies. Rvsm will alter the vertical distribution of air traffic in European airspace as more flights are able to fly at a flight level closer to their optimum. There will also be some changes in the route structure to accommodate the transition area between Rvsm and non-Rvsm airspace. The introduction of Rvsm implies a number of changes for both aircraft operators and aircrews concerning flight into upper airspace. In particular, aircraft entitled to fly through Rvsm airspace have to be approved by the appropriate state authority. This approval is issued for each individual aircraft once the aircraft has received an airworthiness and operational approval demonstrating compliance with the Rvsm Minimum Aircraft System Performance Specification, or MASPS. This necessitates the verification of the aircraft's altitude system accuracy. The more stringent requirements for operating in Rvsm airspace are also reflected in the Minimum Equipment List, or MEL, for an Rvsm-approved aircraft. These MELs comprise 2 independent altitude measurement systems, equipped with cross-coupled static source system with ice protection if located in areas subject to ice accretion, display of the computed pressure altitude to the flight crew, digital encoding of the displayed altitude, signals referenced to a pilot selected altitude for automatic altitude controlling and alerting, and a static source error correction. 1 transponder with altitude reporting of the system in use for altitude keeping, an altitude alerting system, an automatic altitude control system. The state's approval of both the operations manual and the maintenance procedures specific to Rvsm operations will be required. European Rvsm procedures may differ from other Rvsm areas such as NAT or Pacific, especially in case of contingency or loss of Rvsm aircraft capability. In addition to the aircraft approval, Airlines or aircraft operators must request formal operational approval to fly through RVSM airspace. To obtain operational approval, operators shall amend their operations manuals to contain all current procedures for their area of operation and include any RVSM area-specific RT phraseology. Guarantee that any changes in RVSM operation procedures are incorporated into the manuals as soon as they're issued. Review the current flight levels to which RVSM rules apply, noting that there may be differences between regional or national RVSM airspace procedures. Check AIPs and NOTAMs regarding RVSM regularly. RVSM operations require crews to be familiar with procedures and to be notified of any change to such procedures and airspace through initial and refresher training. In RVSM airspace, air traffic controllers will apply different separation criteria depending on the RVSM approval status of each aircraft. The separation criteria are a 1,000-foot vertical separation minimum between RVSM-approved aircraft and a 2,000-foot vertical separation minimum between state non-RVSM-approved aircraft and any other aircraft. Non-RVSM-approved aircraft will be required to operate outside the vertical limits of European RVSM airspace, except when transiting between RVSM and non-RVSM airspace and vice versa. The RVSM status should be indicated by either the notation Equipment Whiskey, if the aircraft is RVSM approved, or just Equipment, if the aircraft is not RVSM approved, regardless of the requested flight level. Additional annotations, such as Equipment X-ray for example, which indicates MNPS lateral navigational approval, which may be required in oceanic RVSM airspace, must be included as well. Operators with full approval should check the continued airworthiness and dispatch status before entering RVSM airspace. In the short-term preparation before flight, specific attention should be paid to any condition that may affect operation in RVSM airspace, and in particular the following actions should be undertaken. An analysis of the reported and forecast weather that may affect RVSM operation requirements. Indeed, since RVSM operation is very sensitive to height-keeping accuracy, turbulence due to the proximity of a jet stream or a storm can influence the capacity of the aircraft to maintain its assigned flight level within tolerance. A review of the manufacturer's and the operator's restrictions concerning RVSM operations. Flight envelope limitations in Mach numbers and altitude or autopilot limitations may induce some specific operational restrictions. A check of the latest NOTAMs regarding RVSM operations in the intended airspace or route. RVSM operations may be suspended temporarily, for example due to an ATC system failure. An indication that the aircraft has state approval to fly within RVSM airspace should be given by writing a whiskey in the ICAO flight plan. During pre-flight preparation, the crew shall check all the elements that may concern the aircraft's RVSM capabilities, such as an examination of the tech log looking for any entry that applies to altimetry and autopilot, the conduct of external checks in accordance with the appropriate include ensuring that the pitot-static ports and the surfaces on which these are mounted are undamaged and free from foreign accretion. In addition, there may be additional RVSM critical areas on the skin of the aircraft, which will also have to be checked for damage or deterioration. A check of the altimeter's accuracy on the ground by confirming that all altitude indications are within the tolerances specified for the aircraft. The altimeter's readings should agree with the altitude or the height of the apron within a plus or minus 75-foot tolerance. A check of the MEL for RVSM capability. In particular, the crew should verify that the minimum equipment standard for flight within any RVSM airspace is respected, such as 2 primary altitude measurement systems, 1 automatic altitude control system, and 1 altitude alerting device. Aircrew should check for any last-minute changes regarding Rvsm status, for a route and airspace to be flown, and flight planning amendments. Flight in Rvsm airspace requires additional crew procedures before entry, namely, in addition to the cross-checking of the altimeters, aircrew should ensure that the altitude alerting system is operative. And, if TCAS-ACAS is installed, leave the mode selector in the TA-RA or normal position, as this is a mandatory requirement and ensures that RA indications are provided in time.
Traffic.
Mandatory reporting points are established at the entry or exit into or out of European airspace. In the Rvsm transition area, flight crews will change from conventional non-Rvsm flight levels to Rvsm flight levels and vice versa. ATC will continue to provide a 2,000 feet vertical separation between any non-Rvsm approved aircraft and any other aircraft. Establishing a safe transition from non-Rvsm to Rvsm airspace may require flight level changes. Non-Rvsm aircraft in Rvsm transition airspace will use the phraseology negative Rvsm. For example, flying westerly on a track 270 degrees from a conventional flight level 330 will result in a change of flight level, possibly by a descent to Rvsm flight level 320 or a climb to Rvsm flight level 340. As a consequence, fuel burn and flight envelope may be modified. Aircrew should be sure they've understood the correct flight level. When approaching the first cleared flight level, and/or when changing flight level in Rvsm airspace, aircrew should seek to keep vertical speed within 500 to 1,000 feet per minute. In the same way, the vertical speed should not exceed 1,500 feet per minute, and crew should ensure that the aircraft neither undershoots or overshoots the cleared flight level by more than 150 feet. The autopilot shall be used as much as possible to capture and keep the assigned flight level. For monitoring traffic at high Mach numbers above flight level 290 with a 1,000-foot vertical separation, aircrew must be extra vigilant concerning the adherence to the cleared flight level and should cross-check when possible with TCAS traffic display information. Altimeter accuracy is of the utmost importance in Rvsm airspace. Therefore, primary altimeters should be regularly cross-checked, at least at hourly intervals. The 2 primary altimeters shall concur within plus or minus 200 feet, and failure to meet this condition will result in the altimetry system being reported as defective. In this case, air traffic